common denominator. When we add fractions, we need to make sure that we have the same denominator, which is the bottom number. Then we're going to add the numerators together, and we're going to keep, which is very important, the denominator. And then finally, we will reduce the fraction if needed. So let's go look at an example. So example 1. In a parallel circuit, there are 4 different resistors. Each has a resistance of 3 ohms. So the first step of finding the total resistance of the circuit is to do the following addition. So each resistor, which is resistor 1, 2, 3, and then 4, each has a resistance of 3 ohms. So we're going to go ahead and then just substitute the 3 in for every R that we see. So we have 1/3 plus 1/3 plus 1/3 plus 1/3. So the next step then, as we have substituted in our value of 3 ohms to each one, is we're going to add. And so how we add is we're only adding the numerators together, and we're going to keep the denominator the same, which is 3. So this becomes 1 plus 1, which is 2, plus another 1 is 3, plus 1 more is 4. So we get 4, and then we keep the denominator, which is 3. And that would be our solution, as this is the first step we find to finding the total resistance of the circuit, which is 4/3 in this case. So let's now go look at another example. And then we don't need to also reduce, right? Because 4/3 is already reduced. So example 2. In another parallel circuit, there are 3 different resistors, which are 4 ohms, 4 ohms, and 4 ohms. The first step of finding the total resistance of the circuit is to do the following addition. So here we have to also substitute in the 4 for each R value we see. So it's 1/4 plus 1/4 plus 1/4. And like before, we're only going to add the numerators together. So 1 plus 1 plus 1 is 3. Then we keep the same denominator, which is 4. And so therefore we have 3/4. And this is the first step of finding our total resistance. So let's go ahead and look at another example. Now we're going to solve for the following. So we have 2 7s plus 5 7s minus 3 7s. So we have 2 different operations. We have addition and then a subtraction. So let's go ahead and first do our addition. So we're going to do that first step. So we'll go 2 7s plus 5 7s. So that is equal to 2 plus 5 is just 7. As we're only going to look at the numerators and add those. And we're going to keep our denominator of 7. So now we have this first term, which is 7/7. And we're going to then subtract it 3 7s from it. So now we have 7/7 minus 3/7. Now we only subtract what's on the top. So therefore, we have 7 minus 3, which is equal to 4. And we keep the same denominator of 7. So our solution is 4 7s. Let's look at one last example. We're going to solve for the following. So here we have 1 6 minus 4 6 minus 3 6 plus 2 6. So we're going to break this down into the first step as 1 6 minus 4/6. Now, what we do is we only deal with the numerator when we subtract. So we have 1 minus 4. So 1 minus 4 is then equal to minus 3 over 6. Then we have the next step. We're going to subtract then. So we have 3 6 from this minus 3 6 plus 2 6. So we're going to deal with this one first. So we have 3 over 6 minus 3 over 6. Now what we're doing is subtracting this negative 3 and then go minus 3. So essentially what we're doing is going minus 3, minus 3. So now we're becoming more negative. And so essentially we have now 6 over 6. Because negative 3 minus 3 is equal to negative 6. We keep our denominator of 6. So this is now negative 6 over 6. And then we're going to add 2 6 to it. And this will be our final step. So we have negative 6 over 6 plus 2 over 6. So now we have negative 6 plus 2. So we're becoming a little bit less negative, as 2 minus 6 is equal to negative 4 over 6. And this would be our solution, except we can reduce this as it's not in its reduced form. And it can be reduced to negative 2/3 as we divided both the top and the bottom by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And so we took out a common factor of 2 to equal negative 2/3.